Assalamualaikum and hello. In this video, we are going to attempt a few examples on how to predict the polarity of the molecules. So let's try example 1. So, example 1, you are given SO3. So this is sulfur trioxide. How you want to answer this question? Everything will relate back to Lewis structure. So step 1, you have to draw the Lewis structure, and step 2, determine the molecular geometry. So we are going to apply all those total electron pair and also the bonding pair and also the bond angle with correct general formula. And after that, step 3, you have to determine whether the dipole moment equals to 0 or not until you get the final answer for the polarity. So let's try to do the first step, step 1. I got sulfur with S6 valence electrons, and then I got 3 oxygen, 3 times 6 valence electron for oxygen, you got 18 valence electrons. The total will be 24 valence electrons. And now, from here, you are going to draw the Lewis structure first. You got S is your central atom bonded to 3 oxygen. And then, what's next? You got 3 bonding pairs. So, it means 6 electrons. So, minus 6 electrons. Bakinya adalah 18 electrons. And I will put my lone pairs at each of them. 6, 12, 18. So, now 18 minus 18 tinggal 0 for this total valence electrons. And last step, pastikan sulfur, your central atom mesti balance. So I got 6 electrons. I will rearrange my lone pairs from any oxygens yang awak prefer. For example, I take it from here. So I will replace this lone pair sebagai bonding pair. So dia akan dapat double bond. Dan sulfur sudah octet sebanyak 8 electrons. So ini adalah Lewis structure for SO3. And then step kedua, kita akan determine the molecular geometry. So kita akan fokus dekat bahagian central atom iaitu sulfur. How many bonding pairs sulfur has? As you see from here, kita ada 1, 2, 3. So you got 3 bonding pairs. And for the lone pairs, sulfur ada 0 lone pairs dan total electron pairs akan jadi 3. So from here, your general formula is going to be AB3 dan basic shape awak adalah trigonal planar untuk AB3. Dan kerana tiada lone pair di bahagian central atom, so that's why molecular shape ataupun molecular geometry masih kekal sebagai trigonal planar. So how you want to draw? Awak akan ubahlah bentuknya dalam bentuk trigonal planar, iaitu di mana awak akan draw bentuk dia sulfur bonded kepada oksigen 1, 2 dan 3. Dan bentuknya macam segitiga. Dan don't forget your lone pairs at oxygen. And this is trigonal planar. So settle untuk awak punya molecular geometry. Specifically for SO3. Dan jangan lupa the final one adalah awak kena draw the bond angle. From here to there adalah 120 degree. So settle for step number 2. And the next one, kita akan determine the polarity. So step number 3, kita nak tentukan polarity sama ada mu equals to 0 ataupun tidak. Benda pertama, awak kena tentukan dahulu which atom is the most electronegative. So the most electronegative adalah terminal atoms. So between sulfur and oxygen, oxygen is more electronegative than sulfur. So what will happen here, awak akan indicate the direction of dipole moment towards oxygen. So how you want to draw that? You are going to draw for each of them. Saya pick from here to there, cross. From here to there, cross. And same case from here to there, cross. So as you see here, inilah awak punya direction of dipole moment. So the next step, awak kena lihat sama ada shape untuk SO3 symmetrical ataupun tidak. Seperti mana yang awak lihat, sekiranya kita ada bentuk trigonal planar, bentuknya seolah-olah seperti triangle. So of course, whichever side you draw is just the same. So kita boleh conclude di sini, the shape SO3 is symmetrical. And then the second point, you can say that bila shape dia symmetrical, maknanya dipole moment can cancel out each other. So you can put as your second point, dipole moment can cancel out each other. And from here, bila dia cancel out each other, the third point iaitu step 3 awak, mu equals to 0. And your final conclusion, you can say that from previous page kita ada mu equals to 0 adalah non-polar molecules. So inilah yang kita nak sebagai kita punya conclusion, iaitu SO3 is a non-polar molecule. So itulah awak punya final answer untuk this example. So saya harap awak clear macam mana kita gunakan daripada awal sampai akhir. Kita gunakan ilmu yang kita belajar, draw the Lewis structure first and then determine the molecular geometry, and after that lihat siapa yang most electronegative, draw the direction of dipole moment, tentukan shape, which one can cancel out each other, and your mu either equals to 0 ataupun tidak, dan final one, the conclusion, whether that molecule is non-polar molecule or polar molecule. So, sedikit tips untuk awak punya bahagian. Sekiranya molekul itu tidak mempunyai lone pair at the central atom dan terminal atoms adalah identical, usually dia akan jadi non-polar. Seperti mana example this one, tiada lone pair di bahagian sulfur dan terminal atom semuanya sama, iaitu oxygen. So that's why SO3 is a non-polar molecule. Tetapi if you got molecules with lone pair at the central atom, so biasanya dia akan jadi polar molecule. Cuma exception for square planar and linear, because dipole moment can still cancel out each other for these two case, dan square planar dan linear molecules akan jadi non-polar molecule, bukan polar, walaupun square planar and linear mempunyai lone pair at the central atom. So let's try one more example, example 2, where we still have the same question. You have to predict the polarity of this molecule, and you got BrF5 in this case. So konsep yang sama, draw the Lewis structure first. So I'm going to start with calculation of total valence electrons. So for Br is 7 valence electrons, and then fluorine you got 5 of them, 5 times 7 valence electrons, awak akan dapat 35 electrons. The total will be 42 valence electrons. And the next one, kita akan tentukan the central will be bromine. Bromine is the most electropositive, so I will draw Br as my central atom, and I got 5 of them, 1, 2, 3, 4, 5, and then bonded kepada each fluorine. And what's next? You got 10 electron used up from 5 bonding pairs. The baki akan jadi 32 electrons. And what's next awak akan isi? 2, 4, 6, and then 12, 18, and total all lone pairs yang awak sudah guna untuk letak di bahagian terminal atoms adalah 30 electrons. So 32 minus 30 electrons, you will get 2 electrons more left. So what is going to happen here? 2 electrons here akan letak di bahagian central, iaitu bromine. So saya akan letak di sini. So what's next? Baki awak akan jadi 0 for all valence electrons. And this is your Lewis structure. So from here, step 1 dah settle. Kita tentukan step 2, iaitu molecular geometry for this one. So molecular geometry kita akan determine from bonding pair. So kita ada bonding pair untuk BRF5 sebanyak 5. Kita ada lone pair sebanyak 1. Dan semuanya ini bergantung kepada central atom awak. Okay, and the next one, total electron pair akan dapat 6. So your basic shape adalah, dalam kes ini, ialah octahedral. Kerana total electron pair awak adalah 6. But due to the existence of one lone pair here, your molecular geometry is going to change from basic shape octahedral kepada square pyramidal. Pastikan spelling awak betul. So, from here you are going to draw square pyramidal where the shape is going to be BR as your center. You got 2 lone pairs at the central atom, and then 1, 2, 3, 4, 5. And then you got 5 fluorine. And as you see here, you got lone pairs at each of the terminal atoms. And what's next? This is your square pyramidal. Dan your bond angle right now between here to here is less than 90 degree. From here, your general formula sudah bertukar kerana awak ada 5 bonding pairs dan 1 lone pair. So your general formula is AB5E. And then what's next? Kita akan tentukan your direction of dipole moment. So between bromine and fluorine, the most electronegative adalah fluorine. So maknanya direction towards kepada fluorine. So how you want to draw? You will take it from here to there, cross. So what can you say from here? Your shape tidak lagi symmetrical seperti mana SO3 tadi. So macam mana awak nak tulis point pertama? Point pertama awak akan tulis the shape for BRF5 is not symmetrical. That is the first point. So due to the shape not symmetrical, so what will happen? Dipole moment cannot cancel out each other. So you can say from here your mu is not equals to 0. And last point, BRF5 is a polar molecule. So inilah final conclusion yang saya mahu. So seperti mana yang saya bagi contoh di sini, awak kena lihat berdasarkan shape untuk molecular geometry. So awak tak boleh berhenti sampai Lewis structure sahaja, awak kena continue sampai awak dapat shape molecular geometry yang betul. Sebab Lewis structure tidak menunjukkan bentuk yang sebenar untuk molekul tersebut. Yang menunjukkan bentuk, the real shape of that molecule is based on molecular geometry. So that's all for this example. I hope you clear how to determine the polarity for any molecule. Make sure you follow the answers that I wrote here in sequence, and please try to do a lot of examples so that you can enhance your understanding. Before we end this video, I want you to revise back what you've learned so far. First step, you have to draw the Lewis structure, and from there, you can determine the molecular shape based on total electron pairs. And after that, from molecular shape, determine whether the shape is symmetrical or asymmetrical. And you can see identical terminal atoms can make it as a nonpolar molecule. Not identical terminal atoms can make it as polar molecule. And for asymmetrical shape of molecule, it will always be polar molecules where your dipole moment cannot cancel out each other. So ini adalah summary for bond polarity for any molecules given, and I hope you clear by so far, and try to do exercise try this 8.0 based on 4 different molecules here. I wish you all the best, and that's it for this video. For the next video, we are going to focus about intermolecular forces. I'll see you in the next one. Bye!